Hello my dear children, a very good evening to all of you. So welcome to Master School Foundation program. So hope all of you wrote the weekend examination on Saturday. So today we are going to discuss the paper briefly. So actually all the 10 questions were very easy in last weekend examination. So I think most of the students will get 10% marks in mathematics. So once let us discuss the questions which you wrote in mathematics on Saturday weekend examination. Now let us start the class today. Now this is the first question in the weekend test paper. If A equal to 1, 3, 2, minus 1, then adjoint A equal to. Options are given as minus 1, minus 3, minus 2, 1, 1, minus 3, minus 2, 1, 1, minus 3, 2, 1, minus 1, minus 3, minus 2, minus 1. A simple problem. This is a 2 cross 2 matrix. We have to find the adjoint of this matrix. According to the definition, adjoint of a matrix means the transpose of a matrix which is obtained by replacing the elements of the given matrix by its corresponding cofactors. That is known as the adjoint of a matrix. But we know one shortcut trick, that is for a 2 cross 2 matrix, if A equal to A, B, C, D, then adjoint A equal to D minus B minus C A. So here we have the trick. If A equal to A, B, C, D, so this is a 2 cross 2 matrix. When a 2 cross 2 matrix is given, to find the adjoint of the matrix, the formula is, if A equal to A, B, C, D, then adjoint of A equal to D minus B minus C A. So this is the formula for finding the adjoint of a 2 cross 2 matrix ABCD. So according to the definition, the transpose of a matrix which is obtained by replacing the elements of the given matrix by its corresponding cofactors. So if you suppose that B is the cofactor matrix of the given matrix A, then we can write adjoint A equal to B transpose. So now by using this formula, where A equal to 1, 3, 2 minus 1 means A equal to 1, B equal to 3, C equal to 2, D equal to minus 1. Now adjoint A can be written as adjoint A equal to. The formula is D minus B minus C, where D means minus 1. So that is minus 1. Next minus B minus 3, minus C minus 2. Next A, where A equal to 1. So for the given matrix A equal to 1, 3, 2, minus 1, the adjoint A is minus 1, minus 3, minus 2, 1. So by observing option A. So adjoint means if A equal to A, B, C, D, this is a 2 cross 2 matrix, we can use this formula when a 2 cross 2 matrix is given. So actual definition is the transpose of the matrix which is obtained by replacing the elements of the given matrix by its corresponding cofactors. That is known as the adjoint of the matrix. So for this problem, A equal to 1, 3, 2, minus 1, the required option is minus 1, minus 3, minus 2, 1. Next, if A equal to 3, minus 1, minus 2, 5, then adjoint A transpose. Then adjoint A transpose, options are given as minus 5 to 1, minus 3, 5 to 1, 3, 5 minus 2, minus 1, 3, minus 5 minus 2, minus 1, minus 3. So just like the above problem, but in the above problem, we have a 2 cross 2 matrix A. Here also we have a 2 cross 2 matrix, that is A equal to 3, minus 1, minus 2, 5. But here we have to find adjoint of A transpose. A transpose is nothing but transpose of a matrix. In the given matrix A, by interchanging the rows and columns, then we will get a matrix that is known as the adjoint of the matrix. So by finding transpose of this matrix, we will get A transpose equal to, by interchanging the rows and columns. The first column is 3 minus 2, write that as first row. Second column is minus 1 5, write that as second row. So 3 minus 2 minus 1 5. So this is A transpose. Now for this matrix A transpose, we have to find the adjoint. So adjoint A transpose, again by using the same formula. If A equal to A, B, C, D, then adjoint A equal to D minus B minus C, A, where this is A, this is B, this is C, this is D. A equal to 3, B equal to minus 2, C equal to minus 1 and D equal to 5. Now adjoint A or A transpose equal to D 5 minus B minus of minus plus 2 minus C minus of minus plus 1 A, that is 3. So 5 2 1 3. So by observing the options, we have 5 2 1 3 in option B. So this problem and the first problem means the above problem. So both are same problems, but in the above problem, so we have found the adjoint of the given matrix A, but here we have to find the adjoint of the matrix A transpose. A is given as 3 minus 1 minus 2 5. So first find A transpose. Transpose of A means we have to interchange the rows and columns of the given matrix. So by interchanging the rows and columns of the matrix A, we got this A transpose equal to 3 minus 2 minus 1 5. Now for this matrix, we have to find adjoint. Adjoint means D minus B minus C. So 5 2 1 3. Next, if A equal to 1 1 1, 1 2 minus 3, 2 minus 1 3, then adjoint A equal to. So these are the options. So by observing, this is a 3 cross 3 matrix. So we know how to find the adjoint of a 3 cross 3 matrix. First, let us find the cofactor matrix of the given matrix A. Here generally let us take the cofactor matrix of A as B. After finding the cofactors of each element of A, then we will get B. By interchanging the rows and columns of the matrix B, then we will get B transpose, that is known as the adjoint of the matrix A. Now here 9 elements are there. First let us find the cofactors of those 9 elements. Let us suppose that B is the cofactor matrix of A. B is the cofactor matrix of A. For a 3 cross 3 matrix, we know plus or minus will come alternately. So plus, minus, plus, minus, plus, minus, plus, minus, plus. So or to find the cofactor, we have to multiply the minor of an element in ith row and jth column by minus 1 power I plus j. We can do just like that, or simply take plus or minus alternately. Now B equal to, first take 1, find the cofactor of 1. So to find the cofactor of 1, let us eliminate the row and column containing 1, means first row, first column. The remaining elements are 2 minus 3, 1 3. 2 minus 3, 1 3, that is a 2 cross 2 matrix. Find the determinant of that matrix. So after getting the minor, multiply that by plus. Okay. By eliminating the row and column, the remaining elements are 2 minus 3, 1 3. So 2 into 3, 6, minus 3 into minus 1 plus 3. So that is minus 3. 2 into 3, 6, minus 3 into minus 1 plus 3. 6 minus 3 is 3 only. Here plus sign is there, so that's why that is 3. Next, take the element 1. To find the cofactor of 1, let us eliminate the row and column containing 1. The remaining elements are 1 minus 3, 2 3. So 1 into 3, 3, 2 into minus 3, minus 6, minus of minus plus 6, 3 plus 6, 9, but here minus is there, so that's why that is minus 9. That is minus 9. Next, take 1. Eliminate the row and column containing 1. The remaining elements are 1 to 2 minus 1, 1 into minus 1, minus 1, minus 2 into 2, 4. Minus 1, minus 4 is minus 5. Minus 1, minus 2 into 2, 4, minus 1, minus 4, minus 5. But here the sign is plus, so plus into minus is minus only. So that is minus 5. Let's take the element 1. Eliminate the second row and first column. Eliminate the row and column containing 1. The remaining elements are 1 1 minus 1 3. 1 1 minus 1 3. 1 into 3 3 minus 1 into minus 1 minus 1 minus of minus plus 1. 3 plus 1 is 4, but here the sign is minus. So that's why that is minus 4. Let's take the element 2. Eliminate the row and column containing 2. eliminate the row and column containing 2. The remaining elements are 1, 1, 2, 3. So 1 into 3, 3 minus 1 into 2, 2. 3 minus 2 is 1. Here the sign is plus, so plus into 1, plus 1 into 1, that is 1 only. Next, take the element minus 3, eliminate the row and column containing minus 3. The remaining elements are 1, 1, 2, minus 1, 1 into minus 1, minus 1, minus 1 into 2, 2, minus 1, minus 2, minus 3. Minus 1, minus 2, minus 3. Here the sign is minus, so minus of minus plus 3. Let's take the element 2, eliminate the row and column containing 2. The remaining elements are 1, 1, 2, minus 3, 1 into minus 3, minus 3, minus 1 into 2, 2, minus 3, minus 2, minus 5. Here the sign is plus, so plus into minus is minus, that is minus 5. Let's take the element minus 1, eliminate the row and column containing minus 1. The remaining elements are 1, 1, 1, minus 3, 1 into minus 3, minus 3, minus 1 into 1, 1, minus 3, minus 1, minus 4, but here the sign is minus, so minus of minus plus 4. Let's take the element 3, eliminate this row and this column. The remaining elements are 1, 1, 1, 2, 1 into 2, 2, minus 1 into 1, 1, 2 minus 1 is 1, but here the sign is plus, plus 1 into 1 is 1. So this is the cofactor matrix of A. 1, 1, 1, 1, 2, minus 3, 2, minus 1, 3. Now, by finding the transpose of the matrix B, then we will get a new matrix that is known as the adjoint of the matrix. So, therefore, adjoint A equal to B transpose. So, by interchanging the rows and columns of this matrix, 3, minus 4, minus 5, minus 9, 1, 4, minus 5, 3, 1. So, by observing the option 3 minus 4, first option eliminated, but here plus 4 is there, 3 minus 4 minus 5 minus 9 1 4 minus 5 3 1. So, option C. In option D we have 3 minus 9 minus 5, but here we have 3 minus 4 minus 5. So, for the given matrix A equal to 1 1 1 1 2 minus 3 2 minus 1 3, the adjoint is 3 minus 4 minus 5 minus 9 1 4 minus 5 3 1. But for a 2 cross 2 matrix there is a shortcut trick, that is if A equal to A B C D, then adjoint A equal to D minus B minus C A. For a 3 cross 3 matrix we can find the adjoint of the given matrix like this. So, let us suppose that B is the cofactor matrix of A. So, find the cofactor of each element of the matrix A. After getting the matrix B, find the transpose of B, means by interchanging the rows and columns we will get B transpose, that is nothing but adjoint of the matrix A. So, here if A equal to minus 1 minus 2 minus 2 2 1 minus 2 2 minus 2 1 and adjoint A equal to x into A transpose, then the value of x is, here you have to find the value of x is. If A equal to minus 1 minus 2 minus 2 2 1 minus 2 2 minus 2 1, then find adjoint of, then find the value of x when adjoint A equal to x into A transpose. So, first we have to find the adjoint of the given matrix A, you will get LHS. RHS is x into A transpose. A transpose means by interchanging the rows and columns of this matrix. After getting LHS and RHS, compare the corresponding elements on both sides, you will get the value of x. The value of x may be any one of these 4 options, that may be 0 or 1 or 2 or 3. So, if we find the adjoint of the matrix A, before finding the adjoint of the matrix A, let us find the cofactor matrix of A. Let us suppose that that is B. So, since the matrix A is a 3 cross 3 matrix, let us take the signs plus and minus alternately, plus, minus, plus, minus, plus, minus, plus, minus, plus. So, for a 3 cross 3 matrix, take plus or minus alternately. So, first take minus 1. To find the cofactor of minus 1, eliminate this row, this column. The remaining elements are 1 minus 2 minus 2 1, 1 into 1 1 minus, minus 2 into minus 2 plus 4, 1 minus 4 is minus 3, but here the sign is plus. So, plus into minus 3, that is minus 3 only. Okay. So, here adjoint of A. adjoint of A. First, let us find the cofactor matrix of A. So, eliminate the row and column containing minus 1. The remaining elements are 1 minus 2, minus 2, 1. 1 into 1, 1, minus 2 into minus 2, plus 4. 1 minus 4 is minus 3, but here the sign is plus. So, plus into minus is minus. So, that is minus 3. Let us take the cofactor of minus 2. Eliminate the row and column containing minus 2. The remaining elements are 2 minus 2, 2, 1. 2 into 1, 2, minus 2 into minus 2, minus 4, plus 4. So, 2 plus 4, that is 6, but here the sign is minus. So, that is minus 6. Let us take the element minus 2, eliminate the first row and third column. The remaining elements are 2, 1, 2, minus 2, 2 into minus 2, minus 4, minus 2 into 1, 2, minus 4, minus 2, minus 6. Here the sign is plus, plus into minus is minus 6. Next, take the element 2, eliminate this row and this column. The remaining elements are minus 2, minus 2, minus 2, 1, minus 2 into 1, minus 2, minus 2 into minus 2, plus 4, that is minus 4, minus 2, minus 4, minus 6, but here the sign is minus. So, that is minus of minus plus 6. Take the element 1, eliminate second row, second column. The remaining elements are minus 1, minus 2, 2, 1, minus 1 into 1, minus 1, 2 into minus 2, minus 4, plus 4. Minus 1 plus 4 is 3, that is plus 3 only. Next, take the element minus 2, eliminate second row and third column. The remaining elements are minus 1, minus 2, 2, minus 2. So, here we are finding the cofactor of minus 2. So, that is why we are eliminating the second row and third column. The remaining elements are minus 1, minus 2, 2, minus 2. Minus 1 into minus 2 plus 2, 2 into minus 2 minus 4, that is plus 4. So, plus 2 minus 4, that is minus 2. Minus 1 into minus 2 plus 2, 2 into minus 2 minus 4, that is plus 4. 2 plus 4 is 6, but here the sign is minus. So, that is why that is minus 6. Next, take the element 2, eliminate the row and column containing 2. The remaining elements are minus 2, minus 2, 1, minus 2, minus 2 into minus 2 plus 4, minus 1 into minus 2, that is plus 2. Minus 2 into minus 2 plus 4, 1 into minus 2, minus of minus plus 4 plus 2 is 6, that is plus 6. Let us take the element minus 2. By eliminating the row and column containing minus 2, the remaining elements are minus 1, minus 2, 2, minus 2. Minus 1, minus 2, 2, minus 2, minus 1 into minus 2 plus 2, minus 2 into minus 2, minus 4, minus of minus plus 4, 2 plus 4 is 6, but here the sign is minus, that is minus 6. Let us take the element 1, eliminate the row and column containing 1. The remaining elements are minus 1, minus 2, 2, 1, minus 1 into 1, minus 1, 2 into minus 2, minus 4, that is plus 4, 4 minus 1 is 3, that is plus 3. So, that is plus 3. So, this is matrix B, that is nothing but the cofactor matrix of A by finding the transpose of B, that is nothing but, so adjoint A equal to B transpose by interchanging the rows and columns minus 3, 6, 6, minus 6, 3, minus 6, minus 6, minus 6, 3. According to the problem, we have adjoint A equal to x into A transpose. Adjoint A is given as x into A transpose. So, that is x into A transpose means by interchanging the rows and columns of this matrix, you will get minus 1, 2, 2, minus 2, 1, minus 2, minus 2, minus 2, 1. Now, we have to get the value of x, adjoint A equal to x into A transpose. In LHS, from each element we can take 3 as common. By taking 3 as common, minus 1, 2, 2, minus 2, 1, minus 2, minus 2, minus 2, 1 equal to x into minus 1, 2, 2, minus 2, 1, minus 2, minus 2, minus 2, 1. By comparing on both sides, we have the same matrix. So, the value of x is 3, that is option D. So, with respect to the given problem, we have the matrix A and we have the condition adjoint A equal to x into A transpose, find the value of x. So, first find the cofactor matrix of A. If we suppose that is B, By interchanging the rows and columns of the matrix B, we got adjoint A. So equate adjoint A to X into A transpose. A transpose means we have to interchange the rows and columns of the matrix A. By comparing on both sides, here from each element we can take 3 as common. After taking 3 as common, compare on both sides, in place of X we have 3. So that is why for the given problem the value of X is 3. Now here if adjoint of 1 0 2 minus 1 1 minus 2 0 2 1 equal to 5A minus 2 1 1 0 minus 2 B, then the values of A B. So minus 4 comma 1 minus 4 comma minus 1 4 comma 1 4 comma minus 1. Here also first find the cofactor matrix of A. Find the cofactor matrix of A. If you suppose that this is the matrix A, if you suppose that B is the cofactor matrix of A, after getting B, interchange the rows and columns, if you will get B transpose, that is nothing but adjoint A. After getting adjoint A, equate the to this matrix. So by comparing on both sides, you will get the values of A and B. Here, if you suppose that B is the cofactor matrix of A, here you will get the signs alternately, plus, minus, plus, minus, plus, minus, plus, minus, plus. So by eliminating the row and column containing 1, the remaining elements are 1 minus 2, 2, 1. 1 minus 2, 2, 1. 1 into 1, 1 minus 2 into minus 2, minus 4, minus half minus plus 4, 1 plus 4 is 5, that is plus 5. Next, take 0. Eliminate this row and this column, the remaining elements are minus 1, minus 2, 0, 1. Minus 1 into 1, minus 1, minus 2 into 0 is 0. Minus 1, here the sign is minus, minus half minus is plus 1. Let's take the element 2, eliminate this row and this column, the remaining elements are 1, 1, 0, 2. So 1 into 2, 2 minus 1 into 0, 0. 2 minus 0 is 2. Here the sign is plus, that is plus 2 only. Next, take the element 1, eliminate second row, first column. The remaining elements are 0, 2, 2, 1, 0 into 1, 0, minus 2 into 2, 4, minus 4. So 0 into 1, 0, minus 2 into 2, 4, that is minus 4. But here the sign is minus, so minus of minus plus 4. Take the element 1, eliminate second row, second column, the remaining elements are 1, 2, 0, 1, 1 into 1, 1, minus 2 into 0, 0. 1 minus 0 is 1 only, here the sign is plus, so that is plus 1. Next, take minus 2, eliminate the row and column containing minus 2. Eliminate the row and column containing minus 2, the remaining elements are 1, 0, 0, 2. 1 into 2, 2, minus 0 into 0, 0. So that is 2. But here the sign is minus, so that is minus 2. Take the element 0, eliminate the first column and third row. The remaining elements are 0, 2, 1, minus 2. 0 into minus 2, 0, minus 2 into 1, 2, minus 2. Here the sign is plus, so that is why plus into minus, minus only, minus 2. Take the element 2, eliminate the third row and second column. The remaining elements are 1, 2, minus 1, minus 2, 1 into minus 2, minus 2, minus 2 into minus 1, minus 2, minus half minus plus 2, minus 2 plus 2, 0. Next, take the element 1, eliminate the row and column containing 1, means third column and third row, the remaining elements are 1, 0, 1, 1, minus 1, 1, 1, 0, minus 1, 1, 1 into 1, 1, minus 0 into minus 1 is 0. Here the sign is plus, that is plus 1. So this is the matrix B. By interchanging the rows and columns of the matrix B, you will get B transpose, that is nothing but adjoint A. So therefore, adjoint A equal to B transpose. By interchanging the rows and columns, 5, 4, minus 2, 1, 1, 0, 2, minus 2, 1. So according to the RHS, we have 5A minus 2, 1, 1, 0, minus 2, minus 2, B. Here we have to get, here by interchanging the rows and columns, so here 5, 4, minus 2, second column, 1, 1, 0, and third column 2, minus 2, 1, but here we have minus 2. So here let us check these. So here by finding the cofactor of 2 by eliminating the row and column -1 into 2 -2, but here the sign is plus, so this is -2. Here also this is -2. Now by comparing the corresponding elements in this matrix and in this matrix, because we have this matrix equal to this matrix, adjoint of this matrix equal to this matrix. So here by comparing, in place of A we have 4, so A equal to 4, in place of B we have 1, so A equal to 4 and B equal to 1. So AB is 4 and 1, that is option C. So find the adjoint of the matrix which lies in LHS. After getting the adjoint of the matrix, equate the two RHS. In both LHS and RHS, compare the corresponding elements. So we got the value of A is 4 and the value of B is 1, that is 4, 1. Next, if A, B, C are the values of the determinants -1, 4, 3, 5, determinant 1, -1, -3, 2, 1, 2, -4, 1, then the ascending order of A, B, C. Ascending means least to greatest, 1, 2, 3, 4, like that. Here 3 matrices are given, they are given as A, B, C. So if you suppose that this is A, this is B and this is C. So now we have to expand the determinants of A, B, C, where A is the value of the determinant of this matrix, B is the value of the determinant of this matrix, C is the value of the determinant of this matrix. After getting the values of A, B, C, we have to arrange them in ascending order, least to greatest value. So first let us find all matrices are the 3 cross 3 matrices. So that A equal to -1 into 5, -5, -4 into 3, 12, so that equal to -17. Next take the matrix B, that B equal to 1 into 2, 2, -1 into -3 plus 3, that is -3, that equal to -1. Next take the matrix C. So modulus, determinant of C equal to 1 into 1, 1, minus 2 into -4, -8, minus of minus plus 8, so that equal to 9. So we got the values of the determinants of the 3 matrices A, B, C as det A equal to -17, det B equal to -1, det C equal to 9. We have to arrange these 3 values in ascending order, least value to greatest value. So by observing these 3 values, among these 3 values, -17 is the least value. Next value is -1, next value is 9. So that's why the ascending order of the values of the determinants of 3 matrices A, B, C is A, B, C only. So that's why option A. So simply find the determinants of these 3 matrices, observe the values of these 3 determinants, arrange them in ascending order. So if A equal to A, B, C, then adjoint A, simple direct formula. So this is a 2 cross 2 matrix. So so many times we used this formula for finding the adjoint of the 2 cross 2 matrices. If A equal to A, B, C, D, then adjoint A is known as D minus B minus C A. So that is option B. So direct formula. Next, if A is a 4 cross 4 matrix, then det A equal to -2, then det of adjoint A equal to. If A is a 4 cross 4 matrix and det A is given as -2, we have to find determinant of adjoint A. Determinant of adjoint A. So we know the formula determinant of adjoint A equal to det A power n minus 1. Det A is given as -2. So -2 power n minus 1. So since A is a square matrix of order 4 by 4, in place of n we can write 3. So here we have the formula determinant of adjoint A equal to det A power n minus 1. So this is the property of adjoint of a matrix. If A is a square matrix of order n by n, then we can write determinant of adjoint A as det A power n minus 1. So that is det A is given as -2 power n minus 1. So, since A is a 4 cross 4 square matrix, we can write this as 4 minus 1, that is minus 2 whole cube. So, minus 8, minus 2 whole cube means minus 2 into minus 2 into minus 2. Minus 2 into minus 2 into minus 2 3 times, minus into minus plus, plus into minus, minus 2 to the 4, 4 to the 8, that is option C. Simple problem. If A is a 4 cross 4 matrix, then det A equal to minus 2, then determinant of adjoint A equal to. So, according to the properties of adjoint of A matrix, we know if A is a square matrix of order n by n, then adjoint A is known as det A power n minus 1. In place of det A, write minus 2 power n minus 1, that is 4 minus 1 3, minus 2 whole cube, that is minus 8. Next, if A is a non-singular square matrix of order n, then adjoint A equal to, so just we used the formula, that is det A power n minus 1. So, just we used that this formula for solving the above problem. So, if A is a non-singular square matrix, non-singular means the determinant of the matrix A is not equal to 0, then adjoint A equal to, that is det A power n minus 1. Next, if A equal to 0 to 1, minus 2 0 minus 2 minus 1 x 0 is a skew symmetric matrix, then x equal to, your options are given as 2 3 5 6, 2 3 5 6. Here we have if A equal to 0 to 1, minus 2 0 minus 2 minus 1 x 0 is a skew symmetric matrix. According to the definition of skew symmetric matrix, a square matrix A is said to be a skew symmetric matrix if A transpose equal to minus A. So, this is A. By finding the transpose and multiply each element of A by minus 1, equate the corresponding elements, you will get the value of x. So, where A transpose equal to minus A, where A transpose means 0, minus 2, minus 1, 2, 0, x, 1, minus 2, 0 equal to minus A. The formula is minus A, means we have to multiply each element of A by minus. Minus 1 into 0, 0, minus 2, minus 1, minus of minus plus 2, 0, minus of minus plus 2, minus of minus plus 1, minus x, minus 1 into 0, 0. By comparing on both sides, we have minus x equal to minus 2, that is x equal to 2. So, this is by using the formula A transpose equal to minus A, or simply here we have minus 2. So, that is why we must have x equal to 2 only, minus 2, 2, minus 1, 1. Here we have minus 2, this is 2. In skew symmetric matrix, all the elements on the principal diagonal must be 0. The remaining elements, this element, this element, this element, this element, and this element, this element, they are numerically same, but according to this sign, they are negative. Here plus 2 is there, minus 2. Here plus 1 is there, here we have minus 1. So, since this is minus 2, in place of x, we must get 2, or you may use this formula A transpose equal to minus A. So, these 10 questions were asked in the last Saturday weekend examination. Okay, now let us start the next concept. So, still now we discussed up to adjoint of a matrix. Now, by using these concepts today, let us discuss the inverse of a matrix. So, inverse of a matrix. So, in general, if for example, if x is there, the inverse of x can be written as 1 by x, that can be written as x inverse. Like this, we have to discuss about the inverse of a matrix. We have to discuss inverse of a matrix. Here the definition is, if we suppose that one square matrix A is there of order n by n, if there exists another square matrix B of order n by n such that AB equal to BA equal to I. I is nothing but the identity matrix. AB equal to BA equal to I or IN. IN means the identity matrix of order 3 by 3. If you take A and B are two square matrices of order 3 by 3, then we can take the identity matrix as I3. So, 1 0 0 0 1 0 0 0 1. Okay. So, if you take A and B are 2 by 2 square matrices, then this can be written as I2. I2 is nothing but 1 0 0 1. Then B is called the adjoint of the matrix A. Adjoint of the matrix A is denoted by A inverse. If A is any square matrix, then its inverse is denoted by A inverse. So, here let us suppose that A is a square matrix of order n by n. A is a square matrix of order n by n. If there exists another square matrix B of order n by n such that AB equal to BA equal to I or IN, then B is called the inverse of A and it is denoted by A inverse. It is denoted by A inverse. Similarly, A is called the inverse of B and it is denoted by B inverse. If A is a square matrix of order n by n, then its inverse is denoted by A inverse. If B is a square matrix of order n by n, then its inverse is denoted by B inverse. If X is a square matrix of order n by n, then its inverse is denoted by X inverse. So, here since B is the inverse of A, means B equal to A inverse. Let us suppose that A is a square matrix of order n by n. That may be 2 cross 2 square matrix or 3 cross 3 square matrix or 4 cross 4 square matrix, whatever it may be, whatever the order of the square matrix may be. So, if there exists another square, if A is a square matrix of order n by n, if there exists another square matrix B of order n by n such that AB equal to BA equal to I, we have to multiply the matrices A and B or B and A, we must get I only. So, 1 0 0 1 or 1 0 0 0 1 0 0 0 1 like that. So, then B is known as the inverse of the matrix A and inverse of the matrix A is denoted by A inverse. So, since B equal to A inverse, in place of B by writing A inverse, A into A inverse equal to, here also in place of B by writing A inverse into A equal to I. So, this is most important formula, A into A inverse equal to A inverse into A equal to I, identity matrix. If A is a square matrix of order 2 by 2, if A is a square matrix of order 2 by 2, then A into A inverse equal to I, that is nothing but 1 0 0 1. If A is a square matrix of order 3 by 3, then A into A inverse equal to I3, 1 0 0 0 1 0 0 0 1. So, let us suppose that A is a square matrix of order n by n. If there exists another square matrix B of order n by n such that A into B equal to B into A equal to IN. IN means identity matrix of order n by n. So, AB equal to BA equal to IN, then B is called the adjoint of the matrix A, inverse of the matrix A. Then B is known as the inverse of the matrix A. Inverse of the matrix A is denoted by A power minus 1, but we have to read that as A inverse. Similarly, B is called the inverse of the matrix A. Inverse of the matrix B is denoted by B inverse. So, since B equal to A inverse, here in the formula AB equal to BA equal to IN, in place of B by writing A inverse, A into A inverse equal to or A inverse into A equal to I. So, the meaning of this is, if you multiply the given square matrix of order n by n by its inverse, if you suppose that A is a square matrix of order n by n, if you multiply the matrix A by its inverse, means A inverse, now you will get I. So, generally already I told you, here x equal to 1 by x, that is nothing but x inverse. If you multiply x by its inverse, you will get x into x inverse equal to, here x into x inverse can be written as x cancel, that is 1 in general. Since these are the matrices A and B, if you multiply each matrix A by its inverse, then you will get the identity matrix, not 1. in general x into x inverse or x into 1 by x equal to 1, but in matrices, if A and B are two square matrices of the same order such that AB equal to BA equal to I, then B is known as the inverse of the matrix A, that is denoted by A inverse. Similarly, B is known as the inverse of the matrix A, and the inverse of B is denoted by B inverse. If you multiply the given square matrix by its inverse, then you will get the identity matrix I. So, if x is any number, then x into x inverse equal to 1. If y is any number, then y into y inverse equal to 1. Like that, in matrices, if you multiply the given matrix by its inverse, then you will get the identity matrix. So, that is A into A inverse equal to A inverse into A equal to identity matrix I. Next, since B equal to A inverse, then A into A inverse equal to A inverse into A equal to I. So, this is the most important formula. The meaning of this is A into A inverse or A inverse into A equal to I means, if you multiply the given square matrix by its inverse, again you will get a square, again you will get an identity matrix. If A and B are 2 by 2 square matrices, then AB equal to BA equal to I2, 1 0 0 1. If A and B are 3 by 3 square matrices, then AB equal to BA equal to I3, that is nothing but 1 0 0 0 1 0 0 0 1. Okay. So, the definition of inverse of a matrix is, let A be a square matrix of order n by n if there exists a square matrix B of order n by n such that AB equal to BA equal to In, then B is called the inverse of A and it is denoted by A inverse. So, similarly, A is called the inverse of B and it is denoted by B inverse. So, since B equal to A inverse, in the formula AB equal to BA equal to in place of B, by writing A inverse, we can write A into A inverse. So, since B equal to A inverse, in place of B, by writing A inverse, A into A inverse equal to A inverse into A equal to In. So, this is the definition of the inverse of a matrix. This is the definition of the inverse of a matrix. So, by using this formula, we can find the inverse of the given matrix. See, next class we shall discuss the properties of the adjoint of a matrix. So, dear students, hope you understood the class today. So, thanks for subscribing Yupp Master. So, thank you.